Swami Vivekananda, in one of his lectures, said that one atom in the universe cannot move without dragging the whole world along with it. Everything in this universe has one common thing, and it is, in its core, that everything is just a combination of basic subatomic particles. All the diversity we witness is just because of the difference in the combination of the particles. Just a step grosser in this diverse hierarchy comes the level of atom. A branch of science is in itself dedicated to find the real structure of this atom. But this branch is so diverse that physicists, chemists, and even some biologists precisely have contributed in searching to give the masses a perfect atomic model. Now, if I just say atom, what comes to mind is a bunch of orbits and electrons revolving in it around the nucleus, which is cool but not accurate or perfect. To start with, a brief history how this theory of shells and orbits became so widely accepted. For the first time, the concept came up in the mind of a great sage of India who was in pursuit of learning the truth behind this universe. He came with the concept of something common in the core of everything. Then, after so many centuries, came all the Western philosophers and thinkers with the same concept. But all these guys knew that something was common in the minute level but didn't know what it was. It is the so called scientists, precisely atomists, who went to the next level and actually said that even the structure of atom is different from one thing to another. Here, in this team of scientists, there are some guys who are commonly known in this history of the structure of an atom as the discoverers of the subatomic particles. First comes the great J.J. Thomson, who was interestingly known as J.J. in the scientific community. He and his student Rutherford were conducting research and experiments on the hottest subject of their period, radioactivity. They, while conducting an experiment, found something spooky. They were conducting a cathode ray experiment and they discovered the first subatomic particle and named it as electron, which had a negative polarity. But this was not the first time that someone observed a subatomic particle. Dr. Brown, who was a biologist, in the year 1827 found some particles irritating on the surface of the object while seeing through a microscope. But this didn't go anywhere as he didn't have sufficient knowledge of physics or chemistry. But some years before this happened, Rutherford, when he was still not a student of JJ, performed an experiment with Giger, who was a fellow scientist. When they tried to build an instrument to measure the charge to mass ratio of alpha particles, they found something interrupting the flow. But then they didn't know anything about an atom, so didn't take it seriously. But now Rutherford, remembering it, conducted the same experiment but in a better way and successfully proved the presence of a large chunk of positive particles in the atom and called it a nucleus and actually invented the nuclear physics. By this time, Niels Bohr had come to Manchester to study the ongoing thing of that time, which was again radioactivity. He, after getting acquainted with the ongoing thing, came to the front and boldly introduced the word quantum into the air and introduced a new concept of fixed orbits for electrons to revolve around the nucleus. This became the next big thing, even though most of the prominent scientists of that day disagreed with Bohr. He boldly took his theory to the hub of physics at that time, which was Germany. Then happened the most unfortunate incident that humanity could witness, the First World War. After the war, Bohr found two of the young scientific dynamites of that time, one a Heisenberg and Wolfgang Pauli. This was all in the early parts of 1900. Within the span of 2 to 3 years, there were two separate groups created. One who supported quantum physics, which mostly had young scientists, and the other who didn't, with so called grown ups led by Einstein himself. So, in the next 10 years, came a ton of theories from both the groups, mostly trying to disprove the theory of the other. But the theory which actually became successful was because of the collective effort of the both groups, which was the uncertainty principle of Heisenberg, which totally shattered the Bohr's model where the electrons were limited to their orbits. Uncertainty principle opened a new arena where electron cloud was introduced in which the position of electron is actually a probability, not a definite one. This created so much fuss in the scientific community that from that day to this day, there has been no real progress in the field. The direction of research actually has been shifted from finding a perfect atomic model to making it complicated by finding new fundamental particles. They have already found about 50 subatomic particles other than electron, proton, and neutron. This makes things so complicated because the basic thing with all the atomic models which is consistent is that an atom is just made up of 3 basic particles and not 50. This violates the law of conservation of mass. When this happens, literally all the atomic models I mentioned earlier, including the latest one, gets crumbled upon. So it seems the work of our 150 year becomes a waste. I'm not saying these guys were wrong, but what they have propounded is not the whole truth. Actually, not at all the truth. I'm just saying it's not worth studying Bohr's model of atom for 10 years of her life before realizing the truth that atoms in fact don't have orbit. Think about it. Meet you in the next video. Peace out.